So hello there and welcome. Now today I want us to look at large-scale manufacture of sodium carbonate. So for this large-scale manufacture of sodium carbonate, we are going to use two methods. So the first method that you are going to look at is extraction of sodium carbonate from Trona. Then apart from that, you are going to look at now Solvay process. So remember, in extraction from Trona, we refine or we are able to obtain sodium carbonate if we have a large water body, especially if the water body is salty. And then this salty water body contains Trona. So if Trona is available, we'll just go to the water body and obtain the Trona from the shores of the lake or the surface of the lake. Then after that, we process this Trona in order to obtain now the sodium carbonate. But now, if Trona is not available, that is now when, so we are going to use the method of Solvay process in order to manufacture that sodium carbonate. So remember, the end product at the end of the day should be the sodium carbonate. So if Trona is available, we're going to refine and process this Trona to obtain sodium carbonate. But now, if Trona is not available, so what you are going to do is that we are going to manufacture our own sodium carbonate. But how do we manufacture the sodium carbonate? So we'll manufacture it by using the Solvay process. Because in this Solvay process, as we are going to look at it, we're going to see that we'll use different raw materials in order to manufacture now the sodium carbonate that you should be having. So now, since you have mentioned sodium carbonate, so the importance of this sodium carbonate is that, so first of all, sodium carbonate can be used in making glass. So for the manufacture of glass, we can use, yes, the different chemicals in the environment like silica, but also we can be able to use sodium carbonate in the manufacture of glass. So apart from that, the other importance of sodium carbonate is that it is used to purify water, or rather it is used to soften hard water. So remember, as we studied previously, hard water, this is water that contains calcium and magnesium ion, or it's water that contains only calcium or only magnesium ion. So that is hard water. So apart from that, you can also see that this sodium carbonate is used to produce, it is used to produce sodium hydrogen carbonate when it is reacted with carbonic acid. As you can look at this reaction, so we have been able to form the sodium hydrogen carbonate by reacting the sodium carbonate with the carbonic acid. So that is another one. So apart from that, we see that this sodium carbonate is also used in cleaning glass. So in cleaning grease from glass or removing stains from glass. So you can also use sodium carbonate in order to do this step. Also, for sodium carbonate is used to lower the pH of swimming pool areas, because if the pH is very high or the pH is very low, so it will mean that this swimming pool water is going now to harm the skins of the people that are swimming. Therefore, for this sodium carbonate, it is used to lower the pH of the swimming pool areas. So apart from that, you can also see that sodium carbonate is used in smelting process. But what is this smelting? What is the meaning of the word smelting? So smelting simply means to extract. So in short, you can say sodium carbonate is also used in the extraction of different metals. Like for example, sodium carbonate can be used in the extraction of iron. Sodium carbonate can also be used in the extraction of copper from copper ore. Also, it can be used in the extraction of zinc from the zinc ore, and also it can be used in the extraction of lead from the lead ore. So among others, those are just sample importance or uses of sodium carbonate. So that gives us the basis and the reason as to why we should be able to study how to obtain this sodium carbonate in order to be able to help ourselves in the future. So this sodium carbonate, as we have said, we see that it can be able to be obtained in two ways. So the first way sodium carbonate can be obtained is through extraction from Trona. So we just go to the water bodies, we extract Trona, we refine the Trona, then after refining the Trona, we obtain our sodium carbonate. So apart from that, the second method through which you can be able to obtain sodium carbonate is by Solvay process. So remember, if Trona is not available, so we are going to undertake Solvay process. Therefore, this Solvay process, remember, as you have said, this is the process whereby we manufacture our own sodium carbonate by using the raw materials which are found in the environment. So these raw materials must be reliable. These raw materials must also be cheap so that we can undertake the Solvay process. So let's now go to the first method, which is extraction from Trona. Then after, we'll go to Solvay process. So extraction from Trona. So for this Trona, we see that Trona is a double salt. So remember, in the topic of salts, we discussed that we have different categories of salts. So the first category of salt, if you remember what we studied, we say that we have salt based on composition, and then we also have salts based on nature. So we have these two categories of salts: salts based on composition and also salts based on the nature. So for these salts based on composition, it simply means the elements that are making up the salt. So those different elements that are making up the salt to fit that compound of the salt. So the salts based on composition example that we looked at, remember we said we had normal salt. So for the normal salt, these are salts that do not have any hydrogen in the compound. For example of normal salt, we have sodium chloride, we have magnesium fluoride, we have potassium iodide, we have sodium nitride. So as long as it does not have any nitrogen in the compound structure, that we say is a normal salt. So apart from that, the next salt based on composition, we went to basic salt. So these are salts that have an OH group, the hydroxyl group. So if any salt contains a hydroxyl group, that means that that salt is a basic salt. So now apart from that, we went to the next one, which was acid salt. And then for the acid salt, remember I said that these are salts that contain hydrogen in the compound. For example, now the sodium hydrogen carbonate that we're talking about. So that is an acid salt because it contains hydrogen. We can also talk about calcium hydrogen carbonate. Since it has that hydrogen, that makes it behave like an acid. We can also have magnesium hydrogen carbonate. So since it has the hydrogen, so the magnesium hydrogen carbonate will behave and react like an acid, among others. So if any salt contains hydrogen part or hydrogen atom, that salt is called an acid salt. Then finally, we looked at double salt, whereby for the double salt now, this is now where we have Trona. For the double salt, remember we say these are salts that contain two anions or two cations in the structure. For example, for our Trona, as you can see, it contains two anions, which is the carbonate and the hydrogen carbonate, which is for sodium hydrogen carbonate. And then for the cations, we have sodium for the sodium carbonate, and then we have sodium for the sodium hydrogen carbonate. So since this Trona contains two cations and two anions, that is the reason why this salt is called a double salt. So as you can see the structure of Trona, we have sodium carbonate dot sodium hydrogen carbonate. So this means they have not reacted. They have just been brought together but have not reacted. So that is the reason why there is that dot there. So they have been brought together, remember, but they have not yet reacted. So like all of them still have the original property. Sodium carbonate has its property. Sodium hydrogen carbonate there also has its own unique property. So those are salts based on composition. And then salts based on nature, we looked at now the deliquescent salt which absorbs water from the atmosphere forming solution. We have hygroscopic salt, whereby these are salts which absorb water and then they form damp solids. Then lastly, we have efflorescent salt. So these are the categories of salt based on the nature. So nature simply means how they behave in the environment. So now we are looking at Trona now, which is a double salt, and for the structure of the Trona is sodium carbonate dot sodium hydrogen carbonate. So like this Trona is mainly obtained in large water bodies whereby there is an inlet and the water body does not have an outlet. So if it happens like that, the water body contains an inlet without an outlet, therefore it will mean that that water body will be a salty water body. So therefore, for Trona is mainly obtained in salty lakes or salty oceans. That is where we obtain this Trona. An example of the water body, we have Lake Magadi. So for Lake Magadi, that is now where we can be able now to easily obtain Trona. So for the Trona, if you know Magadi, then you are good to go. The Magadi that is used in cooking, in softening githeri during cooking, and also in mrenda. That Magadi that is used, that is what you are talking about here right now, the sodium carbonate. So that is not the Magadi. That is what you are talking about, extraction and then Solvay process. That is it. So remember, this Trona is obtained in large water bodies whereby there is an inlet and there is no outlet for that water body. Therefore, the water inside there will remain to be salty. So as you can see, this chart shows how Trona can be extracted from the water body. From the first chamber, which is the extraction, the second chamber is the washery. We go all round to the kiln. After the kiln, heat exchanger, grinding, and then finally the Trona will be bagged. And then from this, not the Trona will be bagged because it will have been refined. So the sodium carbonate that will have been refined will be bagged and then packaged and then taken out to the consumers. So as you can see, this instrument or this machinery. So this is a machinery which is used to now extract the Trona from the bottom of the water body. So this process of mining Trona is called dredging. So as you can remember, in geography we discussed the different methods that can be used for mining. Remember, there was open cast mining, I don't know what's the down cast mining, and now this is now dredging. So if you hear this word dredging, so like what does dredging means? So simply this dredging means this is removing debris or removing soil from the bottom of the water body. So as you can see that machinery, so we have that cap that is sunk towards the bottom of the lake. So from this bottom of the lake, it is able to scoop the soil, or in this case to scoop the Trona and then take it to the surface. So this simply means that is the process that is called dredging. So if you can be able to obtain now this Trona from the bottom of the water body, this process is called dredging. So that is how Trona is mined from the water body, through the process of dredging. So now we go to the chart that you are looking at. So now already we have mined Trona. So after mining Trona, so the Trona is taken to the next chamber, which is now called the washery chamber. So like in this washery chamber, so this Trona is washed. So simply the washing means, so some mud is removed, some small rocks are removed, some plastics are removed, and all the impurities from Trona are removed in this washery by using water. Just in short, by using the water. So this Trona, some water is passed through Trona in order to remove all the traces of impurities and traces of mud and etc. So after this chamber of washery, now the Trona is clean. So after the Trona is clean, it is now taken to the second chamber, which is now called the centrifuge. So for the centrifuge, picture a very big machine. So picture a very big machine that Trona is arranged, or Trona is placed inside. So now, in this big machine where Trona is placed, picture this machine spins and spins very fast. So as this machine is spinning the Trona inside very fast, so two things happen. So the Trona is dried. So we are going to obtain a very dry amount of Trona. So apart from drying Trona, this centrifuge also further purifies the Trona. So two things, remember, happen in the centrifuge. Trona is dried, and then after that, Trona is purified. So after this purification method from the centrifuge, the Trona is now taken to the kiln. So the function of the kiln is now to decompose this Trona. So remember, this Trona is a double salt. And for this double salt, remember we say that it contains sodium carbonate and also it contains sodium hydrogen carbonate. So for this sodium, this double salt sodium carbonate and sodium hydrogen carbonate, now the sodium carbonate is very stable and cannot be able to decompose, Because remember, in the topic of salts, we said that all sodium, potassium, and lithium salts are very stable and cannot be decomposed by using heat. So the reasons we gave was that sodium, potassium, and lithium salts, they are very highly reactive. So since they are highly reactive, they bind strongly now to the anion that they have bound to form the compound, because they are very much highly reactive. That is why it is impossible for us to thermally decompose sodium, potassium, or lithium salts. But there was an exception. If there is a hydrogen in this compound bearing sodium, lithium, and potassium, if there is hydrogen, so this hydrogen is the one that is going to decompose, or hydrogen is going to live together with oxygen and carbon dioxide. So that means that in this case whereby we have Trona, so sodium carbonate is very stable and will not decompose, but sodium hydrogen carbonate is unstable, since the hydrogen and the carbon dioxide are going to decompose off from the structure. So then remember, let's continue. So this Trona from the centrifuge now entered into the kiln. So right here in the kiln, so the Trona is heated to about 300 degrees Celsius. So after Trona is being heated, you can see the equation that happens. So after heating Trona, what is going to happen is that the sodium hydrogen carbonate is going to decompose to form carbon 4 oxide to get sodium carbonate, and then the other one will be water molecules. So that is exactly what will happen. So remember, as we said, so the sodium carbonate is stable, and the sodium carbonate being stable, it is not going to decompose. The only thing in the Trona that will decompose is the sodium hydrogen carbonate only. That will be the one that will decompose, and then it will leave as sodium carbonate, carbon dioxide, and water molecules. So now after the kiln, we have decomposed the sodium hydrogen carbonate. Now the sodium carbonate on its own now, the full sodium carbonate on its own now moves down to the heat exchanger. In the heat exchanger, what happens is that the high temperatures from the kiln are reduced in the heat exchanger. So that is the function of heat exchanger, just to reduce the temperatures of the sodium carbonate that are found, of the sodium carbonate that now have entered into the heat exchanger. So the temperatures of the sodium carbonate are reduced. So from the heat exchanger now, the next chamber is crushing and grinding. Now this sodium carbonate, different machines are going to be used to crush the sodium carbonate and to grind the sodium carbonate in sizable particles that can be packaged and then taken out to the consumer. So that is now that chamber of crushing and grinding. So you just say the sodium carbonate is crushed, the sodium carbonate is ground into tiny particles that can be easily be packaged. Then the last chamber is now the packaging chamber. So in this last chamber of packaging, now this sodium carbonate is put into bags and then transported to the market for the consumers to buy and enjoy the sodium carbonate. So like we see, after extracting Trona from Lake Magadi or the water body, so there is a very high concentration of sodium chloride that remains in the water body. So remember, we said for us to obtain Trona, there must be a salty lake or a salty water body around. So that is what should happen. So after extracting Trona, all the sodium chloride still remains in the water body, because after all, that water body is salty. So for this for this water body, or the salt which is found inside the water, so if the temperatures of this water body are elevated to 40 degrees Celsius, so you see that Trona is going to crystallize and then it's going to be extracted. So again, remember, this salty water is pumped into tanks. So it is fed into tanks, that salty water. So from these tanks, if the temperatures will be elevated to 40 degrees Celsius, Trona is going to crystallize, and then after crystallizing, Trona is going to be extracted. But if the temperatures are maintained at 21 degrees Celsius, sodium chloride is going to crystallize, and then it's going to be extracted. And then that is now how we finish extraction of sodium carbonate from Trona. So again, remember, the last part is that this sodium chloride will be pumped into shallow tanks. So since it will be pumped into shallow tanks, if the temperatures now of this water, of the salty water, will be maintained at 40 degrees Celsius, so Trona is going to crystallize and then extracted. But if the temperatures will be maintained at 21 degrees Celsius, so sodium chloride will crystallize and then it will be extracted. So that summarizes the extraction from Trona. So remember, Trona is a double salt. Why is it a double salt? Because it contains 2 cations and 2 anions. So remember, the reaction scheme begins from extraction through the process of dredging. Then we go to the washer, impurities are removed. We go to the centrifuge, whereby centrifuge further purifies the Trona and also removes water from the Trona. So this water comes from the washery. So all that water is removed in the centrifuge. After that, the Trona is taken to the kiln, 300 degrees Celsius. So in the kiln, the process that takes place in the kiln, it is heated to 300 degrees Celsius. Sodium hydrogen carbonate is decomposed to form sodium, the sodium carbonate. And then this product is taken to the heat exchanger, whereby the temperatures are reduced. Then after that, the Trona is crushed. After crushing and grinding, it is now packaged and then taken to the consumers, to the market. So now, we go to the second method of obtaining sodium carbonate, which is now Solvay process. So remember, for this Solvay process, we said we only undertake Solvay process when Trona is not available. So maybe in school, you can be able to manufacture sodium carbonate through Solvay process. At home, you can be able to manufacture sodium carbonate through Solvay process. So we only undertake Solvay process if Trona is not available. So use the different raw materials in the environment in order now to obtain, or in order to manufacture our own sodium carbonate. So as you can see, this is the chart that summarizes the Solvay process. And then you can see we have 4 main chambers. The first chamber is the first absorption tower. Then the second tower, we have the carbonator, or you can call it the Solvay tower, or you can call it the second absorption chamber. So after that, we have the kiln, then finally ammonia generator. So for this Solvay process, again, don't forget, we only undertake Solvay process when Trona is not available. So the main raw materials for this Solvay process, so the main raw materials, we have brine, which is concentrated sodium chloride. Apart from that, we have calcium carbonate, which is limestone. And then apart from limestone, we have coke, which is just carbon, or maca. We have coke, then after coke, we have ammonia. So ammonia gas is also used in this process, whereby it is first reacted with brine to get ammonical brine. So the choice of these raw materials is that they were chosen because these materials are readily available and very cheap. So maybe, for example, if in the exam you will be asked, so explain why it is advisable to use these raw materials. So you say, it's advisable to use these raw materials because, first of all, the raw materials are readily available, and then after that, the raw materials are very cheap. So since they are cheap now, it is very easy for us to manufacture the sodium carbonate that we desire. So apart from that, we can see that for this manufacture of sodium carbonate, so mostly this plant of Solvay process should be put near a large water body. So why? So we are going to see, in order to constantly keep cooling the carbonator, because in the carbonator it produces very high amount of heat. So apart now from the raw materials, there are materials also which are being recycled in the Solvay process. So the materials being recycled in the Solvay process, we have water, we have carbon dioxide, and apart from carbon dioxide, we also have ammonia gas, which is also being recycled in the Solvay process. Now, as you can see this write-up, so this now summarizes the whole Solvay process and everything else. So the chambers, we have the first absorption tower, as we said. The second chamber we are going to talk about, the second absorption tower, whereby it is also called the Solvay tower, or if you like, you can call it also the carbonator. So in this carbonator, we'll see that we have 2 main reactions that take place in the carbonator. So apart from that, we have the kiln. So apart from the kiln, so the function of the kiln is to produce the carbon dioxide which will be used in the carbonator. So from the kiln, we'll go to the filter. Now from the carbonator is the filter. So the next chamber is the filter. So in the filter, we are going to filter between solid and liquid particles that you are going to see. From the filter, the components goes to the roaster. From the roaster, we'll obtain out the sodium carbonate that we need. So from the roaster, then also there is the ammonia generator. In the ammonia generator, we'll obtain our byproduct, which is calcium carbonate. We are going to obtain ammonia gas, and we are also going to obtain water molecules. So now let's look at the first chamber now in order how to obtain sodium carbonate. So we have the first absorption tower. So in this first absorption tower, we see that ammonia gas combines with brine. So remember, they have not reacted. They have not reacted. So they just combine, but not reacted. So the ammonia combines with the brine in order to form the ammonical brine. So for this ammonical brine, again, remember, it is not ammonia that has reacted with sodium chloride. They have just combined and not reacted. So this product that they form is called the ammonical brine. So, like for this combination, it produces a lot of heat. This combination produces a lot of heat, whereby this heat now will be used now to maintain the activities in the carbonator. So that's the importance of this heat liberated from the combination of ammonia and brine. So it liberates a lot of heat, whereby this heat is used now to maintain the carbonator to continue functioning. So now after formation of the ammonical brine is now pumped into the carbonator. So therefore the next chamber that you're going to talk about is now the carbonator is the next chamber. So remember, the first chamber gives us ammonical brine. Then this ammonical brine is then pumped now into the carbonator. So for this carbonator, it can be called carbonator. If you want, you can call it the Solvay tower. If you want, you can call it now, you can also call it the second absorption tower. So like in this carbonator, we see we have two main reactions that take place. So let's begin with the first reaction. So remember, it is ammonical brine which enters the carbonator, the ammonical brine. So the first reaction to take place here, ammonia gas reacts with carbon dioxide and reacts with water molecules to form ammonium hydrogen carbonate. So again, remember that is the first reaction to take place. So this ammonia, the ammonia is from the ammonical brine. So the ammonia, first of all, is the first one to react. Ammonia combines with carbon dioxide and combines with water molecules to form ammonium hydrogen carbonate. So this CO2 is from the kiln. So it is from the kiln, whereby the kiln constantly generates carbon dioxide. Then this carbon dioxide is pumped into the carbonator from below. Now after this CO2 has entered the carbonator, therefore now this is where the reaction takes place. And also you can see the water molecules are reacting also with the ammonia. So this water molecule is from the ammonia generator. So this water is recycled and taken back to the carbonator, whereby it reacts with the ammonia. So now, since we have explained where everything is coming from, so now the first reaction to take place here is ammonia reacting with carbon dioxide from the kiln and reacting with water from the ammonia generator to get ammonium hydrogen carbonate. So that is the first reaction. So now the second reaction to take place now, this ammonium hydrogen carbonate, this ammonium hydrogen carbonate now reacts with sodium chloride. So that's the second reaction. So the ammonium hydrogen carbonate reacts with sodium chloride, and then in this reaction you are going to get sodium hydrogen carbonate and ammonium chloride. So as you can see what happened there, they have just exchanged the ammonia and sodium have just exchanged the anions. So the anion of ammonia has gone to sodium, the anion of now so I don't think that can work for now. But now you see, like what happened is that for the product to be formed here, so you are going to form now sodium hydrogen carbonate and ammonium chloride. Yes, they have exchanged the anions, so between sodium and ammonia. So you can see the chloride from sodium has gone to the ammonium, and the ammonia had hydrogen carbonate. This hydrogen carbonate has been taken with sodium. Yeah, so we are true. They have just exchanged the anions. So the products to obtain here will be sodium hydrogen carbonate and ammonium chloride. That is the second most important reaction that takes place in the carbonator. So remember, the first reaction we have ammonia reacting with carbon dioxide plus water to get ammonium hydrogen carbonate. Then the second reaction to take place in the carbonator now, this ammonium hydrogen carbonate react with sodium chloride. If they react, we get sodium hydrogen carbonate and ammonium chloride. Those are the two main reactions that take place in the carbonator. So now, from this second absorption tower, now these components are taken to the filter. Now that is sodium hydrogen carbonate and ammonium chloride. So they are now taken from the carbonator and into the filter. So here remember, sodium hydrogen carbonate is in solid form, while ammonium chloride is in liquid form. So these two components are what enters into the filter. So from the filter, the liquid part, which is the ammonium chloride, is filtered out and taken to the ammonia generator. Taken straight to that chamber of ammonia generator. That is what happens. While, since sodium hydrogen carbonate is in solid form, it is taken to the roaster. So remember, the sodium hydrogen carbonate, the solid, is taken into the roaster because it's a solid, while ammonium chloride is taken to the ammonia generator. So that is the essence of the filter, to separate between sodium hydrogen carbonate entering the roaster, ammonium hydrogen carbonate going to the ammonium chloride, the ammonium chloride entering into the ammonia generator. So that is the essence of the filter. Now, these components have gone to the ammonia generator, which is the ammonium chloride, and sodium hydrogen carbonate has entered into the roaster. So here in the roaster, the same process that happened in the extraction from Trona takes place. So in the roaster, the temperatures are 300 degrees Celsius, whereby this sodium hydrogen carbonate will be heated. So if the sodium hydrogen carbonate is heated, it is going to decompose to form sodium carbonate, carbon dioxide, and water molecules. So here in the roaster again, we obtain now this sodium carbonate. Now, since we have obtained sodium carbonate, this is now the main reason as to why we undertook Solvay process. The main reason we undertook Solvay process, remember, was to obtain this sodium carbonate. Now we have manufactured our sodium carbonate. Now, the process that takes place now from here and on, it is only recycling. Now we are recycling everything else from this Solvay process, because already we have obtained our sodium carbonate. Now everything else now will be recycled. Now since you have obtained our sodium carbonate, now this sodium carbonate is extracted and packaged and bagged, ready for the market. So now we are done with the roaster. Now we go to the fourth chamber, which was now the kiln. So the reaction that takes place in the kiln, remember, we said that here in the kiln we have limestone and we have coke. So remember, the main reason for the kiln is only to produce carbon dioxide and calcium oxide. So as you can see, if we hit the limestone, which is calcium carbonate, if we hit the limestone, so the thing you are going to obtain, we are going to obtain the calcium oxide compound and also obtain carbon dioxide. So this carbon dioxide is taken to the carbonator. Also the same way, if we hit coke, which is carbon or charcoal. So if we hit coke, it's going to react with oxygen gas, and then after reacting with oxygen gas, it is going to form carbon dioxide. So this carbon dioxide is taken again to the carbonator. So you see, we have recycled carbon dioxide. But again, there's another thing that happens in this kiln. So remember, when we heated the limestone, we obtained calcium oxide and carbon dioxide. So the carbon dioxide went to the kiln. So the calcium oxide that is formed, it is then reacted with water in a process called slaking. So slaking is reacting any calcium compound with water. So in this case, the calcium oxide that is formed is reacted with water in a process called slaking, as you can see that arrow. So it is reacted with water in the process called slaking. So if this calcium oxide is reacted with water, what is going to be formed? Calcium hydroxide will be formed, as you can see the reaction. So if you react calcium oxide with water in a process called slaking, calcium hydroxide is formed. Now this calcium hydroxide is also taken to the ammonia generator, that second chamber. It is taken to the ammonia generator. So now we are done with kiln. So the function of kiln is to produce the carbon dioxide. If we heat coke in oxygen, it is going to form carbon dioxide. Carbon dioxide is going to be taken to the carbonator. Also, if we heat limestone, which is the calcium carbonate, it is going to form carbon dioxide taken to the carbonator and calcium oxide. This calcium oxide is reacted with water in a process called slaking. So if we slake the calcium oxide, we are going to obtain calcium hydroxide. Now this calcium hydroxide being formed, it is taken to the second chamber, which was now the ammonia generator. Now remember, in this ammonia generator, which is the second chamber, we had ammonium chloride entered into this chamber. You remember the ammonium chloride from the filter? It entered into this second chamber. So apart from this also, we now have calcium hydroxide, which has now also entered into this same chamber. So these two things are going to react. The calcium hydroxide will react with the ammonium chloride. So if these two things react, you are going to obtain, so you are going to obtain calcium chloride as the only byproduct in the Solvay process. So why is it called a byproduct? Because this component is not used anywhere. So after obtaining the calcium chloride, it is going to be discarded. It is not recycled. It is not used anywhere. That is why it is called a byproduct. So we're going to obtain calcium chloride. Also, we are going to obtain ammonia. And then apart from ammonia, we are also going to obtain water molecules. So that is what you're going to obtain in this ammonia generator. So remember, the ammonium chloride from the filter is reacting with the calcium hydroxide from the process of slaking. If these two reacts, we are going to get the calcium chloride salt. Apart from that, you are going to obtain not carbon dioxide, you are going to obtain ammonia gas. And then after ammonia gas, so we are also going to obtain some water molecules also, among others. So this calcium chloride obtained is a byproduct. Byproduct because it is not used anywhere or recycled anywhere. So this water that is obtained is going to be used in the process of slaking, and also some water will be used in the carbonator, even though the carbonator requires a high amount of water in order to continue functioning. Now this ammonia that is formed, the ammonia is taken to the first absorption tower in order to now react again with the brine to form ammonical brine as the process continues over and over again. So as you can see, we have the Haber process down there. So this Haber process now, it's another process which is used to produce now the ammonia gas. But anyway, as we reach that is all in Solvay process. That is all in Solvay process. So if you can be able to understand these steps, this process step by step or one by one, you're good to go. That is all about Solvay process. It is all about understanding in this chamber, this is what happens, in that chamber, that's what happens. So in this Solvay process, remember it began from the first absorption tower, whereby ammonia combines with brine to form the ammonical brine. This ammonical brine combination produces a lot of heat which maintains the carbonator. So these components, remember we said, they'll be taken to the Solvay tower, carbonator, or the second absorption tower, whereby there are two main reactions. The first reaction to take place here, we said, ammonia from the ammonical brine, ammonia reacts with carbon dioxide and water to form ammonium hydrogen carbonate. So remember, that's what we said. Now the second reaction, we said, this ammonium hydrogen carbonate will then react now with the sodium chloride from the ammonical brine to form ammonium chloride and sodium hydrogen carbonate. Now after these two reactions, remember we said, these components will be taken to the filter, whereby sodium hydrogen carbonate being a solid will be taken to the roaster. The ammonium hydrogen carbonate, the ammonium chloride, sorry, the ammonium chloride being a liquid will be taken to the ammonia generator. Now that is from the filter to the ammonia generator. Now in the roaster, the sodium hydrogen carbonate will be heated to 300 degrees Celsius, whereby it's going to form sodium carbonate, whereby this is now the main reason as to why we are undertaking the Solvay process. So apart from that, we are going now to go to the kiln, whereby in the kiln we are going to heat carbon in order to liberate carbon dioxide. This carbon dioxide will be taken to the carbonator. Also in the kiln we have decomposition of limestone, whereby it's going to give carbon dioxide entering the carbonator and also calcium oxide. This calcium oxide will be reacted with water in order to form calcium hydroxide. This calcium hydroxide will be taken to the ammonia generator. In the ammonia generator, the calcium hydroxide will react with the ammonium chloride to form calcium chloride, to form ammonia, to form water and carbon dioxide. Now the calcium chloride is the only byproduct formed here, and ammonia will be recycled, and that is all about Solvay process. So Solvay process is mainly efficient. Why is it that Solvay process is efficient? Solvay process is efficient because it produces minimal pollution. The ammonia that is produced and the CO2 that is produced, it is recycled. So you see, no toxic gases enters the environment because most of it is being always constantly being recycled. Also we see there's recycling of water, and then for this Solvay process it also uses less energy as compared to the other process. It uses very low amount of energy. So lastly, this Solvay tank should be put near water bodies so that this water body will constantly keep cooling the carbonator, because if the carbonator is not cooled, the high temperatures can easily destroy the walls of the carbonator. Now that is all about now Solvay process and as far as manufacturing sodium carbonate is concerned.